What is the infinite sum from k is minus infinity to positive infinity of sine cubed of 3 to the k divided by 3 to the k? What's quite interesting about this is, well, firstly, it's a double infinite-ended sum, so we're starting from negative infinity and going to positive infinity. And one thing I notice almost immediately is we've got a bunch of threes in here. We've got sine cubed and we've got powers of 3 on the top and on the bottom. Interesting. This immediately draws my attention to the triple angle formula for sine. So the formula that tells us what sine 3 theta is. This can be derived either just using the compound angle formulae or using De Mor's theorem, but I'm not going to prove it in today's theorem. I'm just going to state it. So sine cubed of theta turns out to be the same thing as 3 lots of sine theta minus sine of 3 theta all divided by 4. And as I say, I'm not going to prove that in this video. I'm just going to quote it. Okay, cool. How do we use this? Well, let's take this sum here. Firstly, let's write it as a limit. So it's the limit as n goes to infinity of the sum from k is minus n to n of sine cubed of 3 to the k. Well, I'm going to use this identity here. This is going to be 3 lots of sine of theta, so 3 to the k, minus sine of 3 theta, so sine of 3 lots of 3 to the k, but 3 lots of 3 to the k is just 3 to the k plus 1. All of that divided by this 3 to the k here. And this 4 that's on the bottom, that's just a constant, so I can bring that to the front of my sum. Okay, cool. How do we deal with this sum here? Well, I'm just going to split it up into two different subtractions. So this is the limit as n goes to infinity of a quarter of the sum from k is minus n to n of, well, this first thing is going to be 3 sine 3 to the k divided by 3 to the k. So one of those threes will cancel, and I'm left with sine of 3 to the k over 3 to the k minus 1. And with this other one, there's no cancellation. So this is just sine of 3 to the k plus 1, all divided by 3 to the k, like so. Okay, cool. Well, if we stare at this, the thing that we're adding up, the summand, we notice that we've got something minus something. And if we look at the first something and look at the second something, they're awfully similar. And in fact, if we stare at this, we notice that if I take this expression here and replace the k's with k plus 1's, I get precisely this expression here. That tells me that this is a telescoping sum and that all of the middle terms are going to cancel out. And in fact, all I'm going to be left with is the case where k is n, and I'll be left with this term, and the case where k is minus n, and I'll be left with this term. So if that doesn't make any sense, or you've not heard of telescoping sums before, I encourage you just to write out the first few terms of this summation. So plug in k as minus n plus 1, minus n plus 2, and also plug in the last few values of n, so n minus 2, n minus 1, n, and you'll notice that loads of terms cancel out, and we're just left with the limit as n goes to infinity of a quarter, and we're going to have sine of 3 to the minus n all over 3 to the minus n minus 1 minus, and then I'm going to plug in n into this expression, sine of 3 to the n plus 1 all over 3 to the n, like so. Amazing. This is much, much nicer to deal with. Okay, so let's firstly look at this thing here. This is nice and easy to evaluate. As n tends to infinity, 3 to the n blows up to infinity, and sine of 3 to the n plus 1, well, that might oscillate, but it's never going to be bigger than 1. So this numerator here is 1, or at most 1, and the denominator is tending towards infinity, so this term here is going to tend towards 0. And then I'm just left here with this sine of 3 to the minus n divided by 3 to the minus n minus 1. Well, what does that equal? Well, as n tends to infinity, 3 to the minus n tends towards 0. But I've got a 3 to the minus n on the bottom as well. And that's going to tend towards 0. And now it's a pretty famous result that the limit as x tends to 0 of sine of x over x equals 1. And so therefore, this thing here is just going to be a quarter times 1 over 3 to the minus 1. So this part here is going to tend towards 1, and I'm just left with this little minus 1 term there. So it's 1 over 4 times 1 over 3 to the minus 1, and that is just 3 quarters. And that there is the value of this very obscure infinite sum.